All right, welcome to Section 5, Lookup Reference Functions. Now we're starting to get into some of the really powerful, heavy-hitting formulas, so I can't wait to get started. In this section, we're going to talk about named arrays, which is a way to more efficiently work with your lookup formulas in cases that you're using the same arrays over and over. We'll talk VLOOKUP and HLOOKUP, which are kind of two classic lookup functions that are used all the time in Excel. We're going to talk about some formulas like row and rows and columns, which can be really interesting components as part of other lookup functions. We'll go into index and match, talk about how to combine those, how to use match with a VLOOKUP function to do some really powerful stuff. And then we'll talk offset, which is a somewhat complicated but really interesting formula. And we'll do an Excel demo during that lecture where we're going to build this dynamic chart that can scroll and zoom and move, basically do some stuff that most people would never think Excel is capable of. So I'm excited to show you that. We've got two files for download. Got the PDF, Excel for Analysts, Lookup Reference Functions, and the Excel file, Section 5, Lookup Reference. So go ahead and download both of those, and let's get ready to roll. So I want to take just a second to talk about something called named arrays before we dive into specific lookup functions. Named arrays are a really nice tool to help you simplify your lookup functions, especially if you find yourself using the same exact data array in multiple places or across multiple formulas. So, for example, if I have product level data in cells A1 through D6, and I'm using this exact data reference in a number of places, I could give it a name. In this case, I'm calling it apparel. So that in the future, when I write formulas that refer to this array, I can either write A1:D6, or I can just write apparel, which is the name that I've assigned to this array. So Excel will recognize that and understand that I'm talking about the array from A1 through D6. So let's jump into Excel and take a look at the file that we're going to be working with, Section 5 Lookup Reference. We've got 4 tabs here. The first tab, called Hitting Data, is one of our raw data tabs. We've got player names, years, and then a bunch of hitting data metrics in columns C through N. Fielding data, we also have a player and year column, and then some additional fielding data metrics in C through G. We've got a price checker tab, which we're going to be populating once we learn how to use index and match and combine the two. And then we've got scroll chart, which is going to be a really awesome tool that we're going to build using the offset function. We're going to create a chart that can be scrollable and zoomable and dynamic and basically do stuff that most people would never think Excel is capable of. So really excited to share that. But jumping back to the concept of named arrays, let's show an example. Let's go to the Fielding Data tab. If I want to use this entire array on this tab for something like a lookup function, what I can do is click on A1, hit Control-Shift, arrow right, arrow down, so that I've got the entire array selected. And the first way to define this as a named array is to click on this box here, which is the name box, and just give it a name. I'm going to call it Fielding. And now if you go into the Formulas tab, click the Name Manager, you'll see that it's created a new named array called Fielding that refers to the Fielding Data tab, A1 through G, 12,056, which is exactly what I just selected. I'm going to show you one other way to do that, so I'm going to delete this. Yes, close this box. And now instead, the other option is to start in the Formulas tab. Click on this Define Name button. Give it a name, I'll call it Fielding again. I can add a comment if I want. This is Fielding Data. And then click the Data Selector button, and then select that exact same array that I just did. Press the button again and lock it in. So now if I go back to the Name Manager, you can see the same exact thing happened. It created a new named array called Fielding that refers to A1 through G, 1256 on the Fielding Data tab. So there you go. That's how you create named arrays. All right, I want to start with some of the simpler lookup reference functions. So we're going to talk row, rows, column, columns, which typically aren't actually used on their own. They're typically used as components of larger, more complicated formulas, but they do serve a very interesting and, in some cases, very useful purpose. The row function simply returns the row number of a given reference. So if I say, what's the row of A5, it would return 5 because cell A5 lives in the 5th row. Similarly, the pluralized version, rows, just tells me the number of total rows within a given array. This third example down here, it uses a user-defined array, which we'll talk about in, I believe, section 9, the array formula section. Column and columns essentially do the exact same thing. They just return the column number of a given reference, or the total number of columns with an S in a given array. One additional little tip here, if you leave the reference out and just write row with an open-close parentheses, or column, open-close parentheses, it will return the row or column number of the cell in which the formula is written. So let's jump to Excel and take a look at that. Got a blank workbook here. Just to give me some data, I'm going to do a quick rand between 1 to 100 and apply that down and over. So I got a chunk of data. I'm going to hit copy, do my Alt-HVV shortcut, and now I've got an array of random data from 1 to 100 between cells A1 and C12. So let's play with the row and columns functions a little bit. I'm in E1 right now. I'm going to type equals row, open close, enter. That's 1 because I typed it in the first row. And as I apply this down, you'll see how that just updates to return whichever row that the formula is currently residing in. Can also do a column formula here. Open close, hit enter, and drag it to the right, and you'll see the same thing. It just goes up by 1 each time. So that's row and column with no reference. If I wanted to test the row or column number of a specific reference, I could do that. So I could say, what's the row of D6, or return a 6. Or I could say, what's the column, of A3, return 1 because it's in column A. And then last but not least, I could do equals rows of this entire array here, return 12 because it's 12 rows tall. Or I could do columns of the entire array, and it will return a 3 since it's 3 columns wide. So again, these aren't typically used on their own. As you can see, they're kind of simplistic functions, but as components to more interesting formulas, they can serve a really valuable purpose. So there you go, row, rows, column, column. Okay, I want to start by talking about 2 of the most common yet powerful lookup functions in Excel, VLOOKUP and HLOOKUP. These are generally used when you need to combine 2 different data arrays with a common field. So for instance, if I have product-level data in one array, or I have quantity and product ID, and then I have another array of data with the same products and the price information, and I want to merge those data sources so that I have quantity, ID, and price all in one spreadsheet, the lookup is a great tool to use to do that. So there are a few components of the lookup function. It starts with the lookup value. So this is the value that you're trying to match. It's typically the common field that exists between the 2 arrays, the source and the lookup array. The second component is the lookup array. So this is where you're trying to find that lookup value. And the third piece is the column index number. So in your table array, where you're looking for your lookup value, which column of data would you like to return? So that's typically where your variable is that you're trying to pull into your first source array. And then last but not least, you have a range lookup, which basically just says you're trying to match the exact lookup value or something similar. If you're trying to look up the exact value, which you'll use for text strings and words, you'll put a 0 or the word false there. Otherwise, you can put a 1. For instance, if you're looking up a number with a bunch of decimal places and you don't need it to match exactly, you could use that. But just so you know, 99% of the time we're going to use a 0 or exact as a range lookup. So in this example here, again, I have this product level data that I just described. And in one array, I've got product name, quantity, and product ID. And in my second array, I've got product and price. So as you can see, product is the common field between them. And what I want to do is find the price in my lookup array and pull it into my source array. So in cell D2, I've created a price column. I'm going to say VLOOKUP, whatever's in A2, which happens to be the product t-shirt, within my table array G1 through H5. So it's going to go row by row until it finds the lookup value, which in this case, it's finding it in row 5. And then it wants to return the data from the second column over, since that's the column index number. So it finds t-shirt, moves to the second column over, finds the value of $14.99, and returns it in cell D2. And then as you apply this lookup table down, it's going to be looking up sweater, then shorts, then socks, all within this lookup array. So that's VLOOKUP. HLOOKUP works almost exactly the same way. It's really the same syntax. The only difference is that you need to use an HLOOKUP if your lookup array is transposed, which is kind of an odd way of showing the data, but sometimes you'll run across data sets that are built in this way. So it works the same way. The only difference is that it will move column by column until it finds its lookup value, and then move down to a specified row index number, as opposed to moving row by row and moving to a column index number for the VLOOKUP. So again, same exact concept. You just use it when your data is transposed. So two very, very important rules that you need to remember when you use VLOOKUP or HLOOKUP functions. The first is that your lookup value has to be in the first column if you're using a VLOOKUP, or the first row if you're using an HLOOKUP of your table array. So you can't have a table array that goes from column A to D, where your lookup values are a matching column is column B. Excel just doesn't like that. The second rule is that Excel will always return the value from the topmost row if you're doing a VLOOKUP, or the leftmost column if you're doing an HLOOKUP of a table array, if multiple instances of your lookup value are present. So this is a very, very important distinction to make here, which is that if I go back to my VLOOKUP example, for instance, and I'm looking up the value t-shirt in this lookup array, let's say 2 lines in a row had t-shirt as the product with different prices. The VLOOKUP is going to stop the first time it finds the value it's looking for, in this case t-shirt, and return the price in the second column over for that first instance. It's not even going to know that there were multiple instances because it stops at the first one. So the way to get around that is to identify a key that's common to both data sets and unique for every row. That's the key piece here. So it typically takes the form of a concatenation of multiple fields. We'll talk more about those specifics in the text function section, but basically a concatenation, which can be accomplished just using the ampersand sign in Excel, just mashes together 2 text fields into one. So we'll see in our baseball example that we've got players and years, and we're going to need to create a common key based on both of those to properly use the VLOOKUP function. So that's VLOOKUP and HLOOKUP. In the next lecture, we're going to talk about actually putting this into practice by merging our data. All right, enough talking about VLOOKUP and HLOOKUP. Let's actually use it. It's really hard to really learn these formulas until you practice them on real data. So let's go ahead and get some hands-on practice using the VLOOKUP function. Open up the Section 5 Lookup Reference Excel doc, and we'll work out of there. To recap, I've got my Hitting Data tab, which is organized by player by year, with a number of hitting metrics from column C through N. And then similarly, I have a Fielding Data tab, by player by year, with additional fielding metrics here. The goal of this exercise is going to be to pull in those fielding data metrics into columns O through S in my hitting data tab. So this is going to be like my source or master data tab that joins those two sets of metrics together in one place. So what I can't do is just start writing a VLOOKUP function on the player name, for instance, as my lookup value, because I have the data by year as well. So if I looked up a player name in the fielding data array, it's going to find the first instance of that player, if he played in 2010, for instance, but ignore any later instances. So if I have a player who exists in the data set 5 times because he played all 5 years of the data, then that VLOOKUP function based only on player name is going to miss 4 of those instances. It's going to find the first one, it's going to return the associated values, and ignore the others. So the first step that we need to do is create a key column. So in hitting data, right-click and insert a column to the left of column A. You call it key. And to define this function, or this new dimension, I'm going to write equals B2 ampersand C2. This is called a concatenate function, and it just mashes those text strings together to create a new unique field. So there's 2 things that's important here. One, it's unique. There's only one instance of each of these values in this entire column. And 2, it's in the first column, column A. That's very important if you remember the first rule of the lookup functions. So I'm going to jump to fielding data and do the exact same thing. New column A, call it key, and it's going to be equal to B2 ampersand C2. Apply it down. And now I've got my unique common key between both tabs that I can use for my lookup. So the next step that I like to do is just say, all right, let's jump to my lookup data and find which fields or which variables I'm looking to pull into my master sheet. And it's going to be these 5. So I'm just going to paste them here as placeholders. And this is where all my VLOOKUP functions are going to live. So let's start with the position column P. I'm just going to start writing a VLOOKUP. So equals VLOOKUP, open the parenthesis. My lookup value is going to be whatever my key is here. So A2, my lookup or table array, where am I trying to find this player or key name, is in the fielding data from A1 all the way over and all the way down to H12056. And before I do anything else, I'm going to press F4, which fixes that entire array in place so that I can apply this lookup formula down once I've written it and not have this data array shift along with it. So I'll press comma, column index number. It's basically the column where my position field lives, because that's the metric that I'm trying to populate right now, which is in column 1, 2, 3, 4. So column index 4. And then I'm just going to do a 0 for exact match. Close the parenthesis, hit enter. So now if I apply this all the way down, as you can see, it's looking up each player name. If I press F2, dive in, yet the table array or lookup array is not shifting. So there you go, that's position. Now, one other little trick that I use to save myself some time, so you'll notice if I just try to drag this formula to the right, I'm going to get an error. And the reason is, if you look at how the formula changes, watch the lookup value. First it's A2, it shifts to B2 because that was a completely relative array, so I moved it to one column to the right, the A changed to B. But in this case, no matter which column I'm trying to pull in with the lookup function, I'm always going to be looking up the same key field. So the A is never going to change from an A. So what I'm going to do is press F4 3 times to just fix the column but leave the row relative. That way, I can apply this down again. The rows will update, which is what I want. But now if I shift it over, it stays A2, which is what I want. Now you'll notice it's actually the same exact function because nothing is changing for my references. At this point, all I need to do is change the column index number, because remember, position was pulling in the value in the 4th column. putouts is in the 5th column, so I just need to change the 4 to 5. And there you go. I can apply that down. Same thing, I can drag this over. Change the 5 to a 6 to pull in assists, which live in the 6th column over. And then I'll do the same thing for errors and double plays, which live in columns 7 and 8 respectively. And then grab all 3 of those, double-click the corner to apply them down. So, there you go. I've written a lookup function to pull in my fielding data into one master source tab. Okay, so I've showed you how to use an if-error statement back in the logical operators section. I want to revisit that and show you how it works the exact same way, no matter what formula you're using. In this case, we're going to apply it to the VLOOKUP function we've already written. But it's important to revisit it also because it becomes more and more relevant and useful as you start applying it to lookup and reference functions specifically. For instance, if you don't have an exact one-to-one match between your data in your source table and your lookup table, that's going to drive an NA value. And in this case, with the data that we're actually using, I know for a fact that we're going to drive errors because there are players who show up in the hitting data tab but will not show up in the fielding data tab because they only hit, for instance. So when the VLOOKUP function tries to find that player in the lookup array, which is in our fielding data tab, it's going to come up empty-handed and return an NA. So let's see if that's actually happening. First thing I need to do is just apply filters to the rest of the columns that we just created. So I'm going to select row 1, go into the data tab, uncheck filter, and then check it again. That will just reapply the filters all the way out to column T. And now if I look at any of the columns where I've written these VLOOKUP functions, so PQRST, I'll just use the drop-down and see that there are, in fact, NA errors being populated. So what I'm going to do, just like I did in the last section, is I'm going to go into the formula bar, click right after the equals, and write an if-error statement. So if error, open the parenthesis, value is going to be the entire function I just wrote, jump to the end, press comma, and in this case for the position field, since the player doesn't really have a position if he's only in the hitting data set, I'm just going to call it other for now. Close it off, press enter, and then apply that formula down. And now when I refilter, you can see that the NA has changed to an other value. Now for the actual statistics in columns Q, R, S, and T, this is where the if-error statement takes on an even more important role. So right now, I'm getting NA values in all of these columns. And the problem with that is that if I try to select the entire column to see the sum, Excel's getting thrown off because it's seeing these error messages and it's preventing Excel from summing or doing any other statistical operation on the legitimate values. So you can compare when you select, a data column like M or N, where you're seeing average, count, and sum, compared to our calculated fields, which are only showing counts because they have these errors built in that are throwing them off. So what I'm going to do is, again, I'm going to write an if-error statement, jump to the end, and I'm just going to type a 0. I'm not going to use quotes, so that's going to input the actual numerical value of 0 in cases where you get an error. Then when I apply it down, select the entire column, you can see now Excel is able to calculate an average, count, and a sum, which enables me to do any kind of statistical operation that I'd want, just like it's any other numerical field. So I can pull it into a pivot table, I can run stats functions on it, whatever I want. So I'm going to do the same exact thing for the next 3 columns. There are 2 ways to do this. I can just add if errors to each one, which I'm doing now, or I can add the if error to this one, apply it over, and then change the column index number to a 7 and to an 8, just like we did when we first created the function. It's totally up to you, whichever you're more comfortable with, but both approaches work. So now, as you can see, if I select column R, S, or T, I'm getting the average count and sum. And if I look down in the filter, that NA value has disappeared and been replaced by 0. So again, if error, really, really important, especially when it comes to lookup functions. All right, so we've got our beautiful VLOOKUP formula written. It's populating data properly. We've even racked it in if error statement to account for the missing values. All is good. I want to talk about one other tweak that we can make to the table array, and two other approaches that we can use, which can be beneficial in certain situations. So right now, we've written our lookup with a fixed table array. So right now, the lookup is looking for the lookup value within the array from A1 through H12056, and exactly that array. There are two other approaches we could take. The first is to use a named array. So if you recall, in one of the early lectures in this section, we created a named array based on our fielding data. But if you recall when we created it, we hadn't defined this key column A yet. So if you actually select B1 through column H and then Control-Shift down, there's my fielding array. So it basically shifted my named array over. And in this case, my lookup array needs to include column A because that's where my lookup value is going to live. So what I can do is go into the Formulas tab, select Name Manager. Here's my fielding array that we'd created. I'm going to edit that. All I'm going to do is change the B1, delete the B, change it to an A, and hit OK. When I close that, now if I select A1, Control-Shift, arrow right, arrow down, you can see that it's defined as my fielding named array. So now that we've made that little tweak, I can go back to the lookup and just jump into the table array piece of my formula, delete the entire thing, and just write fielding. And as you can see, it will apply all the same values. I can do the same thing here. Again, I'm going to delete the entire table array, starting with the tab name fielding data, followed by the exclamation point. Delete all of that, and just write fielding. And again, Excel will recognize that as a named reference, and it will know exactly what reference that refers to, and populate the correct errors. So I'm just going through cont QRST, and just making the same update here in every case. Note that I'm not putting fielding in quotes or anything because it's not a text string. It's a reference to a named array. And as you can see, Excel is popping up this little box because as I start typing fielding, it's searching through the name manager and seeing if I've created any named arrays with that name. And so in fact, it does find it. So if I can just give it a click, it'll drop it in, and we're good to go. So I can go ahead and apply all those changes I just made down. And once this finishes calculating, you'll see that it's fielding in all cases. So you can see it's a little bit more compact, a little bit of a cleaner formula. The problem that I have with named arrays is that A, I need to remember that I've created this name for it and use the name manager to check exactly which cells that named array refers to. The second is that it's fixed, so if I need to modify or add data, I'm going to need to edit the fielding reference to account for that. So one last option for the table array, which I actually prefer and I use quite a bit, is rather than using a named array, and rather than using a fixed specific array like A1 through H, whatever it was, what I'm going to do is select fielding data. Note that I'm in the table array piece of my formula right now. Select fielding data, just click all of column A, hold down Shift, and all of column H, and hit Enter. And apply that down. So, same exact result. You can see now it's looking up basically any rows in columns A through H, not just down to 12,056. And the benefit of doing this is that now if I get an additional year of data, or if I refresh the data in my fielding data tab, I won't have to touch those VLOOKUPs. I won't have to touch the reference, and I won't have to touch the name manager because every time it performs the lookup, it's going to search every populated row from column A through H. So it's a more effective, more efficient way to use lookup functions when you have a dynamically, constantly changing or updating lookup reference table. So that's my little tip. I use it quite a bit. I'll just show you the same exact thing for the last 4 columns, just so that you're comfortable with it. A through H, hit enter. And again, this just seems to save me quite a bit of time, so that I don't have to remember, all these nuances about how I've defined certain named arrays or exactly what my lookup table is currently defined as in terms of the cell reference. I just always know that no matter what, my lookup's going to work properly. So just apply those down. It'll take a minute to calculate. And there you go. So you see that nothing's changed on the surface because all 3 methods of writing this formula that I've shown you do the exact same thing. It's just that they all have very specific benefits and drawbacks. So there you go. This is what I would recommend using just total column references as opposed to named arrays or fixed arrays. So there you go. Now we have a really, really efficient VLOOKUP function. The next lookup reference function that I want to share with you is called index. And before I even jump in, just hear me out. I know this is going to feel like one of those functions where you read it, you see what it does, and immediately you think to yourself, all right, Chris, why am I ever going to need to use the index function? What it does is so simple that there are a dozen easier ways to do it. And you're right. The fact is, just like row and column, it's one of those functions that no one ever uses by itself. For that very reason, it's so simplistic. But once you start combining it and using index as a component of other formulas, you can open the door to start doing some very cool things. So I promise it will pay off. Just hear me out. So the index function by itself, all it does is return the value of a specific cell within an array. So you're just saying, all right, hey, Excel, here's this array of data or array of cells. I want you to move down to row number 5 and column number 3 and tell me the value that you get. That's it. So syntax-wise, the index formula has 3 components. The array, so what range you're looking at. Row number, which is how many rows down do you want to go? And a column number, which is how many columns over do you want to move. So in this case here, you're going to start from the upper left corner of whatever array you specify, and then move down to the row number and over to the column number. And Excel will tell you what it finds in that cell. So here we're saying, let's index the array from A1 through C5. Let's move down to the 5th row and move over to the 3rd column. And when you do that, it returns 234 because that's the value that it found on the cell that it landed on. So again, very, very simple. Trust me, this will make more sense in just a minute. So hold on your hats. All right, next up we got the match function, which just like index, it's very simple. You're not likely at all to use it on its own, but rather as a component for more complicated nested formulas. So the match function kind of works in the opposite way of index. It returns the position of a specific value within a column or row. So in plain English, basically you're saying, all right, Excel, I'm looking for this value, whether it's a word or a number or whatever, within this column or within this row, and it will return the position of that value. So 3 components to the match function. You've got your lookup value, which is what value you're trying to find the position of, your lookup array, which is where are you looking, and note it has to be a one-dimensional array. I'll tell you why in just a second. The 3rd component is the match type. So if you're looking for the exact value, which you will be 99% of the time, just put it 0. If you're looking for something similar, you can use it 1 or a -1 here. So 2 examples here. In the first case, we're matching the word pliers in column A. So it's looking through column A, starting at the top and working its way down until it finds that lookup value, pliers, and return 4 because it found it in the 4th row down. In this case, we're saying match the number 66 within row 3, so A3 through C3. So Excel starts in the left, moves towards the right until it finds the lookup value, 66, and returns 3 because it found it in the third column over. Now remember how I mentioned it has to be a one-dimensional array? The reason that's the case is that if we said, match the number 2.5 within the array from A1 through B5, how would Excel tell us the position of the number 2.5, in this case $2.50, within a three-dimensional array? Right? There's no single number that will communicate the position of that value, which is why you have to say, look within a single column or a single row, and Excel will tell you the row number or the column number in which the value is found. So that's match. In the next lecture, we're going to talk about how index and match can be combined to do some epic stuff. All right, so we talked about index, we talked about match. Now it's time to talk about how to combine them to do some really cool stuff. In fact, when you combine them, they act almost like a lookup function, but in some cases with even more flexibility, so they can find values in any column or any row within a given array. So let's take a look at an example. It's a little tricky to wrap your head around at first, but once you break it down into its individual pieces or components, you'll see that it actually makes quite a bit of sense. So what we're going to do is we're going to write an index function, but we're going to nest match functions within it. So in this case, we're saying, all right, Excel, let's find a specific price within this little price array from B2 through D4. So it's going to say index that array, B2 through D4. But rather than just saying, move to the third row down and the second column over, which is giving it very fixed directions, I want to make it dynamic. I want the user to be able to input some value that will determine what cell we land on within that array. And that's exactly what the match functions are used for. So if you recall, the first piece of the index function is the array, which is B2 through D4. The second piece is the row number. So how many rows down do we want to move? In this case, the number of rows down that we want to move depends on what product you care about, sweater, jacket, or pants. So what we can do is create a match function that says, okay, we're going to let the user enter whatever product they're looking for in cell B6. And we're going to say, all right, match that product within the range from A2 through A4. And then the answer is going to tell you how many rows down to index. And then similarly, allow the user to select what size they're interested in, small, medium, or large. And when you insert that into a match function, based on the array from B1 through D1, that will tell you how many columns over to move. So it looks kind of like a beast of a function. But when you consider each individual match formula kind of starting inside out, and think about what the output of each of those match functions is, you end up with just a really simple index. So in this case, if you've selected pants and medium, this is just going to say index B2 through D4, go down to the third row and the second column and return the number 30, because a medium pair of pants costs $30. So let's jump into Excel and actually write one of these things from scratch. Same exact concept here. We've got a hypothetical price checker tool. In this case, we have 5 different size options and 5 different product options. And our goal is going to be to populate this cell here with the price using an index function with match components to pull out a certain or specific price out of this array. First thing we need to do is add some data validation, because I want the user to be able to drop down the options for products and the options for sizes rather than having to type it in. So I'm just going to select B10, go into data validation, allow a list. And that list is just going to be the list of products that you're able to choose. Select OK. As you can see, that's worked. Same thing with C10, data validation, allow a list. And the source for that list is going to be all of the sizes that you can choose. In this case, those live in C2 through G2. So I'm just going to use that list. Hit OK. And now I'm able to select any combination of products and sizes. So that's step one. Step two is writing the index match function. So we're going to start with equals index. And what array are we indexing? It's going to be the total array of prices that we can choose from. And since this formula is only going to live in this one cell, I can either press F4 to fix that, or I can leave it relative. Doesn't really matter in this case. But now I'm going to comma over. Now Excel's looking for the row number, so how many rows down to move? And again, it doesn't make sense just to tell Excel, row 1, 2, 3, or 4, because it's a function of what product the user has selected. So I'm going to insert a match function here. I'm going to say match the value that the user has put in cell B10. Okay, where am I going to look for it? In the list of products from B3 to B7, so that right now I have socks selected. This will output the number 1 because it's first in that array. It's in the first row within that array. And so the index function will stay on row 1, which is what we need. Last but not least, match type I'm going to do 0, because I want an exact match here. I'm going to close that off, and that match function is done. Comma over. Now I'm in the column number component of my index formula. So I'm going to just insert another match function. Now we're going to look up what size the user cares about, or what size the user has selected. Comma over to the lookup array, which is going to be the list of sizes from C2 through G2. And then again, exact match for match type. Close that off to finish the match function, and then one more parenthesis to close the index function, and that should do it. So I get 425. Right now I have small socks selected, which looks right. And I can just, pop around different values to make sure it's working. Small pants, 25. There we go. Extra large pants are 28. Extra large t-shirt is 17. There you go. Index match. So I want to talk about one more application of the match function that can be incredibly helpful to save time and work more efficiently with lookup functions. So we're going to jump back to that lookup formula that we wrote in the earlier lectures. So I'm on the Hidden Data tab. I'm looking at cell P2. And I know you're probably thinking, what else could we possibly do to this function? We've worked on reference types. We've changed different table arrays. We've wrapped it in if error. But there's one last piece that we can automate to save ourselves a lot of time in the future, especially if we're going to replicate this function in a number of places. So the piece that I'm referring to is the column index number, or the number 4. If you recall, when we first wrote this series of lookup functions, we applied the first function we wrote over to the 5 columns to the right. So we applied the formula from column P to Q, R, S, and T. And the only thing we had to change to update those functions was the column index number. So we changed the 4 to a 5, the 5 to a 6, 6 to 7, and so on and so forth. We can do even better than that, and we can replace this column index number with a match function that will do the same thing automatically. So what I'm going to do is I'm going to delete the 4 here, and I'm going to write match function. So match. And what lookup value we're looking for, it's going to be the name of the variable, or the variable column header that I'm looking for, in this case, POS or position. And where am I going to try to find that? In the header row of my lookup array, which is in the fielding data tab. So it's going to be fielding data A1 through H1. And then remember, the third piece of the match function is the match type, which will be 0. And I'm going to close the match function off. So now, what I'm doing is, instead of just saying, give me the value from the 4th column, I'm saying, give me the value from whichever column in which you find POS in the header row, which in this case would return the number 4, just like we had. So when I hit enter, you see it returns P for picture. Everything looks good. But before I apply this down and over to additional columns, I've got a little bit more work to do in terms of my reference types and setting them properly. So in order to apply this function down without screwing anything up, I need to make sure that the references in my match formula are properly set. So right now, I just set everything as relative. But what we need to do is, if we leave the P1 relative, Then if I drag this formula down one row, it's going to try to match whatever value's in P2, which is nonsense. So I need to cycle through F4. I'm going to hit it twice until I just fix the row 1. Now when I drag this down, it's going to always pull in whatever the header label is in the first row, so that row number will never change. Similarly, regardless of which variable or which header I'm looking for, those will always live in A1 through H1, so I'm going to fix that completely. And then the last piece that I need to do here is fix the A through H reference in the lookup table. That way I can drag this formula to the right without the A through H shifting through. So I'm going to fix the A through H, and that should just about do it. So I'll hit Enter, test this by applying it down. Everything populates correctly. That's great. And now here's the key. When I apply this over, I shouldn't have to change anything. It should all update properly, which it does. Now, what I'll do is I'll just take those 4, apply them down. And it's calculating. There you go. So, as you can see, the only thing that's changing now in my lookup formula is the lookup value in my match function. So in this case, it's looking up the put-out's header name in the fielding data array, which is in the 5th column over. In this case, it's looking up R1, which is the assist's header name, which is in the 6th column over, and so on and so forth. So it's doing the exact same thing as our original column number, except now it's completely automated. So we can write one lookup function and apply it across a number of columns and a number of rows without having to touch a thing. So a few months after publishing this course, a student messaged me and pointed out there was actually a mistake in the lookup exercise section. And he's absolutely right, and I'll show you what's going on here. If you go into the Fielding Data tab in the Lookup Reference Workbook, you'll actually see that there are multiple instances of certain player keys. And the reason that happens is because certain players may have played in multiple positions, even in the same year. So for instance, Bobby Abreu, in rows 4 through 6, is registered as a left fielder, an outfielder, and a right fielder, all generating the same key because position isn't included. What that means is that our lookup function is searching for his player ID or his player key, stopping at row 4, and returning the putouts, assists, errors, and double plays associated with the first instance of the key, which returns no data. And if we jump to the Hitting tab, Bobby Abreu is right here in row 4. And as you can see, he's got zeros across the board. Even though that year in 2010, he had 242 putouts, 7 assists, 6 errors, and 2 double plays. That data is invisible to the VLOOKUP because now we're dealing with a one-to-many relationship. We've got 1 key in our hitting data and 3 keys in our fielding data. So how do we deal with this? One option would be to actually transform this fielding data set and aggregate it at the player and year level. In other words, remove the position field and aggregate or sum the metrics in columns E through H. But there's an easier way, and it's actually to use the SUMIFS function that we covered in the stats formula section of the course. So let's jump back to the Hitting tab. I'm going to copy the column headers in Q through T, paste them starting in column U. I'm going to give them a different color just so that I can maintain my lookup match functions over here and compare them side by side against this new approach using SUMIFS. So I'll start by typing the SUMIFS formula. Equals SUMIFS. Now if you recall, the first component of the SUMIFS function is the sum range. What's the data that you're trying to actually sum here? In this case, it's my fielding data, column E, which is putouts. I'm going to leave that reference relative, and I'll show you why in a minute. The second component is the criteria range. So where am I looking to meet some criteria? Well, it's a player key, which is column A. I'll press F4 to lock that column in. And then the last piece, criteria 1. What criteria does column A need to meet? And that's gone back to my hitting data. Player key, which is in cell A2. this case, I'm going to fix just the column reference, so that my rows can shift down as I apply this formula down. So there you have it. If I press Enter and apply it down, now that it's calculated, you'll see a lot of matching values with some exceptions. So one exception is Bobby Abreu in row 4, where we had been recording 0 putouts with the VLOOKUP. Now we're recording 242 because we're essentially summing all of the values in column E, where column A equals Abreu BO 012010, of which there are 3 instances. Similar case with the next player. There are 3 instances of his name as well. In his case, he generated 16 putouts at second base, 11 at third base, and 16 at shortstop, which totals 43 putouts. With the VLOOKUP approach, we captured 16, which is only the first instance. But now that we've shifted to a SUMIFS approach, we're capturing all of those putouts, all 43. And because I set my reference types properly, what I can do now is even just shift this to the remaining columns, since I know these columns are sequential, and that allows me to basically just allow that column E to shift to F, G, and H. And I can just grab those cells, double-click, and apply them down. So there you have it. We've accounted for the fact that we no longer had a one-to-one relationship with our key, and we've achieved the results that we're looking for using a statistical function instead. Now, the one caveat I will make is that this worked because we're trying to return numerical values here, which SUMIFS can understand. If instead we're trying to return position, for instance, which is a text field, there's no way I could have used a SUMIFS to accomplish this because Excel doesn't know how to add P and 2B and LF or any other text string. So again, if you're working with values, sometimes you can use VLOOKUP or a SUMIFS interchangeably. Other times, you'll need to use just one or the other. All right, so the last lookup reference function that I want to talk about is called offset. Offset's kind of a lesser-known function, but it's a really useful one when it comes to doing some kind of unique, powerful things, which I'll show you in the next lecture. But basically, just to give you some background, it's similar to index. It returns the value of a cell within an array, but it can also return a reference to a specific range of cells, which can be very useful when you want to create dynamic arrays. And I know that sounds kind of like gibberish. It will make more sense in the next lecture, I promise. So basically, syntax-wise, offset starts just like an index function. You determine a reference, which is what's your starting point. Typically, that's a single cell reference. And then you have a rows component, which tells you, okay, how many rows down should I move? And then columns, which is how many columns over from the reference should I move? And if you just leave it at that, it will function exactly like an index. It'll give you the value of whatever cell it lands on. What makes offset different is that it includes these 2 additional components, height and width, which lets you return a multidimensional array rather than just the value within a single cell. So these are optional, which is why they're shown surrounded by brackets. And if you leave those blank, if you just close out your formula after the columns indicator, again, it will be just like an index, and height and width will default to 1 and 1. So you'll return the value of a cell that's 1 row tall and 1 column wide. Quick pro tip here, I'm showing you all these functions like offset and index match, which have very specific, and in some cases very particular applications. Don't get too caught up in using them just for the sake of using them. So don't use an offset or an index match when a simple VLOOKUP will do the trick. So with that, that's how the offset function works. I'm going to show you how it can be used to build a really cool dynamic scrolling chart in the next lecture, so get ready. So before we dive into the scroll chart example, which is really, really cool, I promise, I want to show you one other very common application of the offset function, which is to combine it with a simple stats function called COUNTA. Now, there's an example of this in the homework exercise at the end of the chapter, but I want to show you a very basic example just to give you a sense of what it's all about. So in this workbook that I'm looking at here, obviously it's extremely complicated. I've got 6 items in a list in column A. What I can do is use the COUNTA function, just type equals COUNTA, to count the non-blank values or cells within a range. So in this case, my range is the entire column A. When I close that off, it will return a 6, since there are 6 non-blank values right here in column A. Now, what does that have to do with offset? Well, what if we wanted to return the last item in the list, no matter how long that list is? So let's say last item, and right here in D2, let's start with an offset function this time. So what we're going to do here is we're going to offset from the start of the list, A1, and the number of rows we're going to move down is a count A function. So count A essentially means that we're making this offset function dynamic so that it can identify the last item in the list, even as data is added or removed and the size of that list grows or shrinks. So we'll take the count A of the entire column A, which we know returns a 6. And now before I move on, this is telling me that I'll move 6 rows down from A1, which would take me to A2, 3, 4, 5, 6, 7, which is blank. We've gone 1 row too far. So all I need to do to account for that is add a -1 right there. And now I don't want to shift any columns because I only have 1 column of data, so I'm going to put a 0 there. And I can ignore the height and the width for now, just close off my parentheses. So now when I hit enter, it tells me my last item is a line, which is pretty cool. But the beauty of it is that I can add values here, and that value from D2 changes accordingly. So grape, cherry, and same goes as I delete values, that updates as well. So that's pretty cool on its own. The other really valuable application of this is actually with charts and graphs, where you can define your source data using an offset with count A, so that as you add new data to your source array, your chart will update automatically. So for more info on that, check out my Excel Data Viz Advanced Charts and Graphs course, and I'll show you some demos of how that works. But there you go, basic combination of offset and count A. All right, so it's time to put Excel to the test. Let's see what we can do to create a chart unlike most people have ever seen in Excel. Go ahead and open up the Section 5 Lookup reference file. I'm going to jump to the last tab here, the Scroll Chart tab. And our goal here is going to be to create a chart with a dynamic data reference. We're going to do that using the offset function. And the goal is going to be to create a chart that we can zoom and scroll to change the view of data that we're looking at. So we're going to step beyond the static charts that 99% of Excel users are out there using. So a little bit of housekeeping items. The first is that we're going to use scroll bars, and to do that you need to insert them through the Developer tab. So take a look at the top of your Excel screen. If you don't see the Developer tab, what you're going to need to do, and this is in 2013, is go into the Home tab, click Options, Customize Ribbon, and then over here on the right, you should see a checkbox next to Developer. Yours is likely unchecked, so go ahead and give it a check, press OK, and you should see it pop up. If the user experience is a little different in Excel 2010, or if you're using an older version, honestly, just Google it and make sure you have your Developer tab activated. So I'm in Developer. I'm going to go to the Insert button and find this scroll bar form control. I'll click it. I'm going to drag out one next to this scroll line. Press OK, and I'm going to do the exact same thing and drag a second next to that zoom line. And if you want to edit the appearance of them, you can Control-click them. I made that one a little fat, and I'm a perfectionist, so I'm going to want them kind of as close to identical as I can. That's fine. So now what we're going to do is edit what these scroll charts actually do. So I'm going to right-click the first one and click Format Control. So this is basically saying what values can this scroll bar take, what cells are they linked to, basically what are these scroll bars going to control. So in this case, the scroll bar, I want to have a minimum value of 0. I'm going to set the maximum value to 6. Increment of 1 and page change, that's fine, I don't really care about that. The cell link is going to be cell D16, which is right next to the scroll index text. So that's it for that one. I'm going to right-click the zoom scroll bar, click Format Control again. In this case, I want it to have a minimum value of 1, a maximum value of 12, and you'll see why in a little bit. The 1 and the 10 are fine. In this case, the cell link is going to be D17 next to the zoom index text. So hit OK, and there you go. We've set up both of our bars, and now if you just click through, you'll see that they're linked to the cell values in D16 and 17. So that's step 1. Step 2 is going to be to work with some named arrays that are going to feed our chart data reference. So I'm going to go into Formulas, Name Manager. This is my fielding name array. I can just kind of leave it as is. I'm going to create a new one. The first one's going to be called Scroll Index. And that's just going to refer to cell D16. So I press the little data selector, press it again, so scroll chart D16. OK? And create another one called Zoom Index. And that's going to just refer to cell D17. So I've created 2 new named arrays called Scroll Index and Zoom Index. So this is where it gets a little bit more complicated. I've got my scroll index, I've got my zoom index. The next piece that I need is the dynamic array that's going to feed into my chart. And I'm going to need at least 2 of these. One for my X values, which are the months, and one for my Y values, which we'll start with by plotting impressions. If we wanted to plot both impressions and clicks, we would need 2 named arrays for each series of Y values. So let's start with the X values here. I'm going to create a new named array. I'm going to call it X values. And note exactly how you write these named arrays, because we'll need to use the exact same syntax and the exact same name with the same capitalizations and lowercase letters once we feed them into the chart. So I'm using a capital X and then a lowercase v. So my X values are going to refer to a formula, and that formula is going to be an offset. So I'm going to type offset, and my X values live in column B, so my reference or starting point will be B3. And then remember the second piece of the offset function, which is how many rows down do you want to move. It's a little trickier now because we don't have the helper box kind of guiding us through the formula. This is kind of the Wild West. We're on our own here, so we need to remember how the offset formula is built. In any case, the second piece is how many rows down, and that depends on what the value of the scroll bar is, which lives in cell D16, which is tied to the scroll index named array. So I'm going to type scroll index here. The second piece, how many columns over do I want to move? In this case, my X values or my months only live in column B, so I don't want to move any columns over at all. So I'm going to type a 0 there. The next piece is going to be the height of the array that I want to return. So this is dependent on the zoom scroll bar. So whatever value the zoom scroll bar has output into D17 is the height of the array that I want to feed into the chart, because that's the number of months that I want to look at in a given view, either crunched down to 1 or 2 months or zoomed out to all 12. So that's just going to be my zoom index named array. And then last but not least, the width of my reference is just going to be 1 because it's 1 column wide. Close the parenthesis and hit OK. And that's created my X values field. I'm going to create my Y values field in the exact same way. So it's going to be an offset function. The only difference is that the starting point, rather than being B3, is going to be whichever field I want to plot here. So let's plot impressions for this example. So my starting point will be C3. And then remember how many rows down is going to be scroll index. How many columns over? 0. What's the height? Zoom index. And what's the width? 1. Close the parenthesis and hit OK. And now I've created an X values array and a Y values array, along with my scroll index and my zoom index. So I'm going to go ahead and close out of the name manager. The last piece that I need to do is populate this chart that I've basically set up a shell of right here. So I'm just going to right-click, select data. I'm going to add a data series here. Series name is going to be impressions, since that's the field that I'm going with for my Y values. And the series of values, rather than just selecting an individual cell or range of cells here, what I'm going to do is make a selection just to give me the beginning part of this reference, because I want the scroll chart and the exclamation point. But I'm going to delete everything following the exclamation point. And I'm going to replace all that with Y values, written exactly as I had defined it. So uncheck that, hit OK. You can already see in the background things are starting to populate. And now in my horizontal or category axis labels, I'm going to press the Edit button, and the range is going to be, again, rather than this fixed array, I'm going to make a selection just to get the starting point in place, delete everything following the exclamation point, and I'm going to put X values here. When I hit OK, you'll see that our X-axis has updated to show names of months. And there we go. So, as you can see, we're charting out impressions. And now as I move the zoom scroll bar, the width of our view, which is actually captured by the height of this array, is shifting. And similarly, if I shift the scroll index, now our entire view, however wide or however zoomed we set it, is moving from left to right in the chart. So, right now I'm looking at 6 months of data, and I'm seeing how it trends month over month. As I zoom in, I can look at just a single date at a time, or 2 months or 3, and so on and so forth. So if we wanted to include clicks as a secondary Y value, that's easy enough to do. We just go into the name manager, create a Y values to named array, and then just change the starting point of that offset function to D3, and the rest will be exactly the same. So there you go, a scrolling, zoomable, dynamic chart using the offset function. All right, nicely done. You've completed the lookup reference chapter of the course. Definitely one of my favorites. Hopefully you found some useful stuff in there. And for those of you who want a little bit more hands-on practice, I've got some great homework exercises for you. So go ahead and open up the Excel Homework Exercises workbook. We're going to start on the Lookup Functions tab. We've got 3 instructions here. This is going to use the next 2 tabs in gray, state abbreviations and state income. Once you've wrapped up the Lookup Functions exercises, go ahead and jump right to the index and match example. And then last but not least, I've got some great demos for offset and count day. Good challenging questions. Hopefully these will help you really get a good grasp of how these functions work. So again, the answer file is available in the course resources, but if you need help, don't hesitate to reach out. Good luck. All right, now that you've wrapped up Section 5, Lookup Reference Functions, it's time to move on to Section 6, Text Formulas. And as you may have guessed, this basically covers any formula or function in Excel that allows you to work with or manipulate text strings. So we're going to start with some basic capitalization-based functions like upper, lower, and proper. We'll talk quickly about the trim function. Then we'll go into concatenate, which is basically how you join text strings together. Talk about how to convert text to values and values to text using the text and value functions. We'll talk about left, mid, right, which are really powerful ways to extract pieces of text strings. And last but not least, we'll go into search and find and go into some Excel examples to show you how that works. So as usual, 2 files to download: Excel for Analysts Text Functions, which is a PDF, and then Section 6 Text Functions, which is an Excel file. So go ahead and give those a download, and let's get started. All right, let's kick things off by talking about 4 pretty simple text functions: trim, upper, lower, and proper. Starting with trim, basically all it does is remove any leading or trailing spaces from a text string. And while that might seem like kind of a trivial thing for a function to do, it's actually really, really important. And that's because if 2 text strings are identical, except for the fact that one has a trailing space at the end, they'll look exactly the same to you, but Excel will treat them as totally different values. So that can totally wreak havoc on things like lookup or match functions that are trying to find 2 exact values to match. So trim will make them equivalent. And honestly, it's a nice best practice to get in the habit of using, just to standardize your text fields. Lower, upper, and proper, these are just capitalization-based functions, So lower will just convert the characters of a reference array to all lowercase. Upper will convert all the characters to uppercase, and proper will capitalize the first letter in each word of a text string. So let's dive into Excel and see what we've got to work with. I've opened the Section 6 Text Functions Excel file, so go ahead and open that up and follow along. Just one tab here, it's called Raw Data, and looks like we've got some names here: gender, address, city, state, zip, email, telephone, and national ID. So we're going to be working exclusively with this one tab and this one file as we work through this section. So our first challenge is to create 2 new fields for first and last name. And what we want to do is convert to proper case and also trim out any potential leading or trailing spaces. And as you can see, these all look, just like normal first names. But if you select any cell and click in the formula bar, you'll see that Jennifer, for instance, has a trailing space after it. Chad does not. Susan does not. Wayne does. But as you can see, it's really manual, and the only way to tell is by actually clicking into the value of each cell. So what we're going to do is create a new column. And just right-click column B, and I'm going to do insert. I'm going to call this new column proper first name. And so I'm going to start with just the proper function. So equals proper. Open up the parenthesis, select A2, and close it. As you can see, that converts Jennifer in all caps to Jennifer with just a capital J. Now, I don't need to create a new column and take the trim of this version. I can just add trim to this and write both functions at once. So I'm going to say equals trim proper A2, and close the parenthesis. And then when I apply this down, Jennifer will no longer have a trailing space. So let's do the exact same thing after column D. Then a right-click E, insert, call it proper last name, equals trim, parenthesis, proper, parenthesis, D2, and then close the 2 parentheses off, hit enter, and apply it down. There you go. So we've used proper to clean up the first name and the last name columns. All right, next up we've got the concatenate function, which is honestly one of my favorite functions. It's one of the most underrated and powerful functions in Excel. Really what it does is combine text, cell values, or formula outputs into a single text string. You can either type equals concatenate if you choose, or you can just use the ampersand symbol, which does the exact same thing. So note that you can combine just cell references and the strings that they contain. You can combine those with user-inputted text strings surrounded by quotes, or you can combine them with other formulas which will pull out pieces of text strings to be concatenated. So in our first example here, we've got a first name Daniel, last name Wright. First case, we're just combining the 2, A2 and B2, which gives us this following output, Daniel Wright. The second example, we're concatenating the same 2 fields, except adding a space between. So the output is Daniel space Wright. And then the third and fourth examples integrate the left function, which we're going to talk about in the next lecture. So let's jump into Excel. And we're going to do 2 things here. We're going to create a full name column and a full address column. So I'm going to right-click column F, insert a new column. I'm going to call it full name. So the goal here is to create a full name field that takes the proper first name, the middle initial, and the proper last name with spaces between them. So all I'm going to do is type equals, and the first text string that I want, which is proper first name, B2, then ampersand. Now remember, I need a space between this and the middle initial. So in quotes, I'm going to write a space. So it looks like nothing's there, but I'm actually inserting a space into my resulting string. So then another ampersand to the middle initial and another space, one last ampersand, and then the proper last name. So rereading this formula, I've got B2, so proper first name, then a space, middle initial, then a space, proper last name. So if I hit enter, I expand this out. As you can see, this is working beautifully. Similar case for full address. I'm just going to right-click column L, insert a new column, name it full address. And in this case, I'd like to do something similar. I just want the street address followed by a comma and a space, then the city, comma space, state, comma space, zip code. So same idea here. Start with equals H2, ampersand, comma space, in quotes, ampersand, city, ampersand, comma space, in quotes, ampersand, state, ampersand, comma space, quotes, ampersand, zip code. So street address, comma space, city, comma space, state, comma space, zip code. Press enter, expand this out so that we can see it. And there you go. So that's a basic concatenation to pull together multiple text strings. All right, next up we've got left, mid, and right, which return a specific number of characters from a location within a text string. In other words, they extract pieces of text from a larger string. We'll also talk about the len function, or length, which returns the total number of characters in a string. So syntax-wise, really straightforward. They just start with the text reference. Left basically says, I want to return a certain number of characters from the left of this text string. So if you were to say, from the left of string A3, or the string within A3, return 2 characters. Excel's just going to start at the left of this string and return the first 2 characters that it finds. Right works exactly the same way. It just starts from the right of a text string and works its way to the left. So if I said, to the right of this text string in A7, give me 3 characters back, it's going to return 100 because those are the last 3 characters in the string. And then mid has one additional component to it, which is the start number. And it's basically just what you use when you want to pull a text string or pull characters out of the middle of a string. So here we're saying, from the middle of this string in A5, I want to start in position 4 and return 5 characters, and that will return 02215, because 0 is in the 4th position in the string. And then, last but not least, len, which speaks for itself, just counts the characters. In this case, there are 17 characters within the sample text string. So let's jump to Excel. We're going to do some work on the telephone column in column N. So I'm actually going to create 3 new columns here, and I'm going to name them area code in column O, prefix in column P, and line number in column Q. And I'm going to define area code as these first 3 numbers of the telephone number. I'll define prefix as the second chunk of 3 numbers within telephone number. And then line number is going to be the last 4 in the number. So we're going to practice all 3, left, mid, and right, in order to accomplish this. So for area code, since it's the first 3 characters of the string, I'm going to use a left function. So equals left, N2 is my text reference. Number of characters, it's going to be 3. I'll just close that off and apply down. There you go. Prefix, we're going to need a mid function because we're pulling characters out of the middle of this text string. So the text is going to be same reference. N2, the start number, is basically where's the first character that we want to return. And it's in 1, 2, 3, 4, 5. It's in the 5th position. And the number of characters that we want to return is 3. Press enter. 376, that looks correct. 289, there we go. And last but not least, line number is just the last 4 digits of the telephone number. So we're going to use right. Again, the text reference is N2, and we want to return 4 numbers from the right. 3064 looks good. Apply it down. And there you go. Simple left, mid, right functions. All right, so I want to take a minute to talk about 2 functions called text and value, which can be really useful functions when Excel is treating your text like values and your values like text. So what the text function does is it converts a numeric value to text and assigns a particular format to it. Value, on the flip side, converts a text string that represents a number into a value so that you can treat it as such. So for the text function, two components to the formula. The first piece is the value. This could be a number, a formula that evaluates to a number, or a reference to a cell containing a number. And the second piece is how you want to format your text. Whether you want to format as a date, as currency, certain number of decimal points or digits, and so on and so forth. So one really common example where you might run into issues between texts and values is dealing with the zip codes. So let's jump into Excel again and take a look at our zip code field, which is in column K. For those of you who don't know, the traditional or standard zip code should have 5 digits. The problem here is that certain zip codes which began with a 0 have gotten that leading 0 stripped off by Excel because Excel is treating this as a value and it deems the leading 0 to be irrelevant. So what we need to do is create a new column here. So I'm going to right-click column L and insert a new column. I'm going to call it New Zip. And so, as a first effort, let's try just using a text function here. So equals text. Our value is going to be the zip code value in K2. And then for format text, I want to see if I can give it 5 digits. So in quotes, I'm just going to hit the pound or hash sign 5 times, close the quotes, and then close the parenthesis, and hit enter. And this worked for all the 5-digit ones. The problem is it didn't add the 0 to my 4-digit zip code because the 0 had already been stripped from it. So we need to get a little bit more clever here. So what I'm going to do is incorporate a logical statement with a len function to treat the 4-digit zip codes a little bit differently. So what we're going to do here is we're going to start with the text function we already have since we've gotten pretty far along. And we're just going to start with if the length, so if len of K2, which is our zip code field, close the parenthesis, equals 5, then the value of true is we're going to convert it to text with 5 decimal points. And that's that. When I come over to value of false, here's where we're going to tell Excel how to treat the zip codes with only 4 digits. So we're going to say, if the length of K2, close the parentheses, equals 4, then I'm going to just grab this and just copy paste, save me a little bit of time. Then we're going to convert the K2 value to text, but I'm going to make one edit to the format. I'm going to force the first digit to be a 0, and then finish with 4 pound signs. And then I'll just close this off with 2 more parentheses, and that should just about do it. So press enter, apply it down, and as you can see, the cases where it had only had 4 digits now have that leading 0 added back in. So again, just to revisit this formula, we're saying, if the length of the zip code equals 5, just convert it to text with as many digits as you can. If the length equals 4, convert it to text and force the first digit to be a 0. So we used combination of logical operators, the length function and the text function to create a new proper zip code field. Okay, so we talked about the simple left, mid, right functions, and we determined very specific number of characters to return in each case. That works great for things like phone numbers, which are extremely consistent and standardized. But realistically, there are many situations where we're going to deal with a variable number of characters to return. So, in other words, what if we need the 3 characters after the ampersand sign, or all of the characters preceding the dash? Questions like that can't be addressed by the left, mid, right functions alone. You need something like the search function to help you accomplish that. So search, which is a personal favorite function of mine, and hopefully soon to be favorite of yours, is a really powerful function that searches for a given character or string. And then if it finds it, it returns the position of that string. If it doesn't find it, it returns a value error. So syntax-wise, there are three pieces. Basically, it starts with, what are you looking for? What character or string? Where are you looking for it? And then an optional piece called start num. So by default, search will start at the beginning or left of a text string and move left to right until it finds what you're looking for. If you set start number to something different, it will basically start after a certain number of characters. So in this case down here, we're looking at a text string in cell A11. So we're saying, okay, search for the percentage sign within A11. It starts in the left and counts 1, 2, 3, 4, 5, 6, 7, 8, 9, finds it in the 9th position and returns the number 9. In this case, we're using the optional start number component of the formula. We're saying search for the percentage sign within the same text string, but this time start at the 10th character. So we're skipping over the first percentage sign, finding the second instance of the percentage, which lands in position 13, so returns a 13. And then the next two examples start to show you how you can integrate the search function with others like left, mid, right to add that dynamic element that I was referring to, which is the most common usage of search. You won't often see search on its own. A little tip before we jump to Excel, the find function works exactly the same way, but it's case sensitive. So by default, when case sensitivity isn't a factor, I just use search. So jumping to Excel, what we want to do here is work with this email column and create a new one. So I'm going to right-click O, insert a column. I'm going to call it username. And I'm going to define the username as basically whatever precedes the @ sign in the email. So jenniferjmcgrath@gmail.com would translate to a username of Jennifer J. McGrath. So I obviously want to return characters from the left of the text string in column N. But if I start to write that, and I get to the number of characters piece, what the heck do I write here? So for Jennifer J. McGrath, it looks like 15 characters. Close, 16. Yeah, I can get her right. But then if I try to apply this down, I'm getting pieces of the address because obviously it's not a standard number of characters that I need to return. So what I need to do is replace the number of characters part of this function with a search. So I'm going to search for the @ sign surrounded by quotes because it's technically a text string. I'm going to search for it within N2 and then close that off. So now what we're doing, so we're saying start at the left of this email, and I want you to basically return the number of characters it takes for you to find the @ symbol. So if I were to close this out right now, we'd be close. But you see how we basically include the @ symbol with it? That's because it's finding the @ sign in the 16th position and returning 16 characters, which by definition includes the @ sign. So all I need to do, I'm just going to delete that last parenthesis, and since I'm still in the number of characters component of the formula, just going to add a -1, and then close it off. And now all that does is it says, okay, return 1 less character so that I don't include the @ sign. Now when I apply this down, there you go. Regardless of where the @ sign occurs in the string, the search function allows me to always update how I'm defining username so that I'm only getting the piece preceding it. So really powerful function. This is just one application of it. I'm going to show you a few more applications in the next few lectures, so stay tuned. All right, so it's time to share with you a top secret, very, very powerful combination of formulas that I use just about every single day of my life, called if is number search. So sounds a little crazy. It's a combination of three functions: if statement, is number statement, and search statement, all rolled into one. And basically what it does is it helps you classify data based on cells that contain specific strings of text. So in other words, you might have a crazy, messy string of data that contains bits and pieces of useful information that you can use to create new data dimensions or classify new categories of data. The if is number search allows you to basically mine through the text string, pull those out and create those dimensions or classifications however you need to. So to interpret this formula, which looks a little crazy at first, it's always easiest to start from the inside and work your way out. So let's start with the search function, which we just walked through. Basically, you're just searching for text within a certain string of text. And that will return either a value, which is the position where it found the text you're looking for, or an error if it doesn't find the text. So then taking that out one step further to the isNumber formula, all that's saying is, did you get a number when you did that search function? Yes or no? If you got a number, it means it's returning the position of that thing you were looking for, meaning it found it. If you don't get a number, it means you got an error because you didn't find it. So all those two together are saying is, did you find what you're looking for or not? So then when you take one more step back and look at the if statement, all you're saying is, if you found what you're looking for, then return this value if true. Otherwise, if you don't find what you're looking for, return the value if false. So going back to our discussion on if statements, keep in mind that you can nest as many of these together as you want. So you can create extremely deep and complex categorical rules using this combination of functions. So let's jump into Excel, and I'll show you one example of how we can do that. So I'm going to create a new column here. Right-click O, create a column right after email, and I'm going to call this provider. And basically what I want to do here is determine which of these users uses Gmail, which uses AOL, and which users use Hotmail. And so what I'm going to do is I'm going to use a combination of if, isNumber, and search functions to search for those keywords, Gmail, AOL, and Hotmail, in order to categorize these people into their providers. So I'm going to start with if, open parenthesis, isNumber, open parenthesis, search, open parenthesis, and now I'm on the find text component of the formula. So what am I looking for first? I can do this in any order, but the first thing I'm going to look for is Gmail. I'm going to look for that text within N2. And then syntax-wise, it gets a little bit complicated, but as soon as you finish the within text piece, you're going to close out two parentheses, and then comma over to the value if true. So by this point, my formula is saying, if you search for Gmail within cell N2 and you find Gmail, what do you want to return? So I'm going to return Gmail. When I get to the value of false piece, here's where I can start my next if statement, because I'm going to nest a few if statements in here. So instead of rewriting if isNumber search from scratch, I'm going to go into the formula bar, grab everything I just wrote up to the comma, copy it, and then paste it right afterwards. So now the value of false is, okay, if you didn't find Gmail, let's do another search. So if isNumber search for AOL within N2, then we're going to call that AOL. And then the exact same logic here for my third if statement. Just going to copy that piece, paste it after the comma. And the last thing I'm going to look for is Hotmail within N2. If I find it, call it Hotmail. And now my last comma takes me to that end-all be-all statement, that value if false. If all of these tests are false, what do I want to show here? And let's just call it other, and then close out a bunch of parentheses, 1, 2, 3, to get me to the beginning, and hit enter. So I know that was kind of a beast of a formula, but each piece is actually quite simple when you think about what it's really doing. So if I apply this down, as you can see, it's pulling out or identifying the provider from each of these users and classifying them or categorizing them accordingly. So if I look at the drop-down, you can see that everyone's fallen neatly into one of those three buckets. So there you go. That's just one example of how powerful this combination of if, isNumber, and search can be. All right, so I've got one more tip to share with you guys to close out this text function section. But before I do, let's just look at how far we've come in this section. kind of scroll through this Section 6 workbook, considering what we started with, it's actually pretty impressive where we've ended up. So we've been able to create and define and modify a number of different fields and new data dimensions just using combinations of pretty simple text functions. So hopefully this gives you a sense of just how powerful they are, especially once you learn how to combine and manipulate them in interesting ways. So the last tip that I'm going to share with you guys is one that's deceivingly difficult and tricky to get right. So remember when we did the username formula in column P, where we said, I want to return a variable number of characters from the left of the email field. And we used the search to say, give me everything up to the @ sign. What if we wanted to return a variable number of characters from the right of a text string? So let's take a look at how we might do that using this national ID field. I'm just going to create a new field right next to it. I'm going to call it short ID. And I'm going to define that as just all the characters that follow the dash in the national ID. So you can see in some cases it's 3, in some it's 4. I believe in other cases it's 2 or 5. The bottom line is that I can't just insert a strict number of characters to return from the right. I have to get more clever than that. So why don't we just start with a right function, because we know that's the right starting point. And we're going to say, all right, I'm going to return characters from the right of U2, or my national ID field. And now the number of characters, again, it can't just be a number. So you might be thinking, well, this is obvious. Just use the search function and search for the dash within that text. Boom. And hey, you're right for row 2. But before you go and hold a parade for yourself, let's apply it down and see what's going on. So the problem is it works great for the first 2, but as soon as you get to an ID that requires a 4-digit short ID, you're only returning 3. So something's not quite right yet. And the reason we're seeing this discrepancy is that the right function is working from right to left. The search function, on the other hand, by default searches from left to right. So when you say search for the dash, it's finding the dash in the 3rd character. So we're returning 3 characters from the right every single time. It doesn't care if there are 3, 4, 5, or 100 characters after the dash, because the search is going left to right, not right to left. So let's step back and put our mathematical hats on for a second and say, okay, if there's no simple way for us to define via functions or formulas what number of characters occurs after the dash, what pieces can we easily define with the tools that we have? So, A, we can define the number of characters through the dash, which we've already done using the search function. B, here's the missing link. We can return the length of the entire string using the len function. So if we have the length of the whole string, and we have the length of the string through the dash, then think about what the difference of those two equals, and that's exactly what we need. So if you subtract everything up through the dash from the length of the entire string, you'll end up with the number of characters to the right of the dash. So kind of an unusual way to think about it, but that will get the job done. So I'm going to just delete my search function here and start over. So again, I'm in the number of characters component of this function. So what I'm going to do is say, let's take the length of U2, subtract all the characters up to the dash. So I'm going to do a search for the dash within U2 and close it off with 2 parentheses. So now we're saying, okay, I want you to take a certain number of characters from the right, or then define the number of characters as the whole string, minus everything up to the dash, and return what's left over. And when I apply this down, boom, there you go. It accounts for the fact that there may be a different number of digits to the right of that dash. So you can do the same thing. For instance, if we wanted to poll everything after the @ sign for the email, let's just do email service here and say equals right of this text length of the text minus search for the @ sign within the text. Boom, gmail.com, AOL.com, hotmail.com. So, again, a great reminder that if you're creative, there are an infinite number of ways to combine these functions to do almost anything you want to do. So with that wraps up the text section. I hope you enjoyed it. Up next, we've got another great section, date and time functions. So stay tuned. So there's one other text function that I didn't get a chance to cover, and I wanted to introduce it here in the bonus lecture. And that function is called substitute. And the purpose of the substitute function, as you might expect, is to substitute a character or string of characters from within a text field and replace those characters with something new. Now, the beauty of substitute is that it also allows you to define which instance of a character to change. So looking at our text function workbook here, I'll refer to the telephone number field in column R, which has two different instances of a dash. And let me show you how the substitute formula can replace either the first or the second dash from within this text string. So I'll just insert a new column after column R, and let's call it new phone number. And here I can type a substitute function, and it has 4 components. First component is the text that I want to edit. In this case, it's telephone number, cell R2. And now here are the old text. This is where I indicate the character or string of characters that I'd like to change. In this case, I'm going to change the dash. And my comma over the new text is what I want to replace that dash with. So instead of a dash, let's put a pipe here. And since this is text, I need to surround it in quotes. And finally, the 4th component of this function is that instance number. So if I type 1 and close the parenthesis, as you can see, 618 dash is replaced with 618 pipe. And now if I go back into that function, it changed the 1 to a 2. Now you can see that second dash changed to a pipe. And this is helpful when you're trying to extract very specific text strings out of a field, and you need to create a single unique identifier. So in this case, I've replaced 2 dashes with 1 dash and 1 pipe, and now I can use search, mid, left, right functions using matpipe to help me isolate pieces of this string. So there you go, I can just apply this down. As you can see, in every case, it replaces the second instance of the dash. And there you go, that's the substitute function. All right, it's homework time. So for those of you who want a little bit of extra practice with text functions, I've got some good challenges for you here in the Excel homework exercise workbook. So I'm on the text functions tab, and here you can see we've got a bunch of text strings for product keys that really messy. There's a lot of information that's kind of embedded in there, and what we're going to do is use our full arsenal of text functions to extract meaningful bits of it. So we're going to populate these columns B, C, D, all the way out through column H, based entirely on the text strings in the product key column. So looking at the instructions, we've got 6 steps here. We're going to use everything we've got: left, mid, right, search. We're going to use the if is number search combo, substitute, all of that good stuff. So give it a shot, see how you do. If you need to look at the answers, that file's available for you. Otherwise, best of luck.